Okay, so somebody asked a really good question about the Tic Tac Alpha game, and I want to talk about another way of thinking about it and why that works, but also why it may be a bit rough to think about it that way. So I had a student who told me that, oh, well, what I did for Tic Tac Alpha was I figured there are, the two options for this square. Either the smiley face can be in that square or not in that square, right? And then there's two options for this square, same thing, smiley face can be in there or not. Two options for this one, smiley face can be in there or not, and so on for each of those spaces. So if we think about that, there's a couple issues with this problem. Of course, you're absolutely right. That is a perfectly reasonable, although big way to represent this. It's maybe a little bit overkill, because what we end up with, if the smiley face can actually be in any of these spots, right? That means it could be in two of these spots at once. So, for example, if we say it could be in here or not, could be in here or not, could be in here or not, then we could have a Tic Tac Alpha playing field where we end up with a smiley face in like three different spots, right? Because we're saying could be in here, might not be in here, right? Could be in here, might not be in here. I don't seem to be able to change the color of my dot. Here we go. Let's try that. Right? Could be here, could be here, could be here, maybe not, could be in all of them, could be in whatever. So it's certainly overkill, but just for fun, let's talk about how we would do that and how we would represent that and how many states there are. So let me make a little bit more space. And let's talk about all the different states and how we would represent them, right? So in my video, the previous video, I said that we could say that we have sort of 9 states, right? And I called them state 1 through 9, but really what I should have said is there's a state where the smiley face is in that spot. And there's another state where the smiley face is in this spot, and so on, right? And if we draw out, well, hang on, smiley face. And what I think I did is I called this guy state 1 and this guy state 2 and this guy state 3, right? And that's the full state of the board at that point, right? And so if we think about, come on, let me get some more space. If we think about what we're doing in this red situation, then really what we have is we have one state where, let's see, there's a smiley face in the first one, so that's true, but all the others are false. And then we have another state, right, where there's a smiley face in this one, so sort of true if we're doing a Boolean, and the others are false. So we get the 9 states that we already had, right, 1 through 9. But then we get a bunch more states, right? Because we have, we have the state where there's a smiley here and a smiley also there, but nowhere else, right? And we have the state where there's a smiley there and a smiley there and nowhere else. And we have the state where, I mean, we can keep going, right? We could list all of them, but then we have some states where we have like these 3, right? All the 3s and all the 4s and so on. And the question is, how many states are there? Now, if we were to, actually, before we count the number of states, let me just show you that we can still make a, we can still represent the space like this. We could say, all right, here's state 1, and I'm just going to draw in here that state 1, maybe I'll color it in to show you there's a smiley face in there. So that's like my state 1, and we said my state 2, can't make tic-tac-toe boards anymore, is just this and so on. So we could, write that if we make a move to the right, we end up there, and if we make a move to the left, and this is all beautiful. And then we're going to have a bunch of states like this one over here, which actually are, they're legitimate states. What do we got? We got that and that and that. But there's not going to be any arrows in and there's not going to be any arrows out because we can't really talk about what does it mean to move right or what does it mean to move left on this guy. And so that's sort of a problem. Well, okay, let me try again. It's not a problem. You can have a bazillion states. There's nothing wrong with having a bazillion states. It's just we want to try and pick less than a bazillion if we don't really need a bazillion. So the question arises, how many states, if we go with this red approach where every single space, we say, okay, here's how we're counting the spaces. Every single space is going to have a choice of yes or no. Then we have to multiply all those numbers together. So that top left square, there's 2 possibilities. And then we need to multiply that by the 2 possibilities in the top middle square, because if we just think about those 2 squares here, and if we just think about just those 2 top squares, right? We could have a, true, where there's both of them have smiley faces, or true, false, or false, true, or false, false. And we end up with 4 different options. And if we add another box, right, that could be true or false, then we end up with 8 options because we have all of these guys with true in this box, and then all of these ones again with false in that box, right? Ooh, that's not an 8 there, though. That should, yes, of course, you've seen this already. Where's my little eraser tool? Woo! Okay. So that's really 2 times 2 times 2, right? Which equals 8. And if you think about it, we have 9 different squares. And so if you have a different square, if you have true or false option for where's the smiley for every single square, we end up with 2 to the 9th different states. And 2 to the 9th is pretty big. Right? 2 to the 9th states is 512 states. And that's a lot of states when only 9 of those states are actually states that you could find yourself in. And so, yeah, saying that, thinking about this as every, the smiley could be there or couldn't be there, yes, sometimes you need to think about that. And sometimes you're right. You need to think about, you may end up with a situation where you do, in fact, have 2 to the 9th states. But in this particular case, we can simplify it a bit. So let me see if I can think about how to help you think about how one might simplify this. So let's draw our tic-tac-toe board again. And I guess what you need to think about when you're thinking about what are all the states that I have is maybe start out by kind of drawing, in this case, what are the different options that I have. And if you draw what are the different options you have, what do I need to keep track of? And honestly, as in this particular example, as long as I know where the smiley face is, I'm golden. That's all I need to know, right? This is a pretty simple one, a simple problem in terms of the number of states you use. Go look at Tic-Tac-Beta and so on, and it'll get a little bit more complicated, but this is sort of the, I hope this helps to explain a little bit why my answer to Tic-Tac Alpha is just 9.